afternoon, everybody. We're going to go ahead and get started. I'm Dr. Allison Huntley. Today, our speaker is Dr. Kenna Archer. Dr. Archer has been at Angelo State since 2010. She got her PhD from Texas Tech in 2012, but she didn't want me to tell you all that she is a Baylor Bear at heart. She specializes in environmental history, 19th and 20th century U.S. Her talk today, Castle Bravo, Environments and War in the Atomic Age, is in recognition of the 70th anniversary of the largest detonation of a nuclear weapon by the in U.S. history at, how do you say it again?
Bikini Atoll.
At Bikini Atoll in the Marshall Islands on March 1st, 1954. So, join me in a round of applause for Dr. Archer.
That was beautiful. Can y'all hear me okay in the back? Because I can definitely project if I need to. Okay, I'm gonna take just a minute to turn on a timer because otherwise I'll go about 3 hours. And y'all probably don't want that. That would not be particularly kind of me. I guess we can get that door. Sure. Can I give you this back? Thank you. Okay, so firstly, thank you for coming out. I recognize that a lot of you are my students and you're getting extra credit for being here, but still you are taking time out to learn about history just for funsies, and I think that should be celebrated. So thank you. As Dr. Huntley said, I'm going to be talking about Castle Bravo, which is the largest U.S. detonation. It is definitely not the largest detonation in world history. The Soviets have that honor. They've actually detonated the top 5 bombs. We're 6th with Castle Bravo. But we're going to talk about Castle Bravo just a little bit. So a little bit about the outline to my approach, just because I recognize that some of you are taking notes here, right? So what I'm going to do is I'm going to divide it into 3 different sections. And firstly, we're going to talk just a super tiny bit about the science of developing nuclear weapons. For the scientists in the room, don't judge me, okay? We're going to keep this super basic. Okay, super basic. But we're going to talk about the science of developing nuclear weapons. Then we're going to talk about the atomic testing program in the United States. And then, because I'm an environmental historian and this is what I like, we're going to talk about the ecological consequences of the nuclear program. And before we start, I do at least have to ask, how many of you saw the Oppenheimer movie? We just had like this ginormous Barbenheimer cultural fad over the summer. I did not see either movie. I'm a bad historian. So if you did see Oppenheimer, in the Q&A we can even talk about what you felt like was accurate or not based on this. So let us go ahead and get started with a little bit of the science here. So Castle Bravo is the largest detonation, right, in U.S. history, but before we get to that point and before we get to Bikini Atoll, we have to go backwards a little bit. And by a little bit, I mean way further back than most of you actually care to go, okay? We have to go all the way back to the 1890s and some scientific breakthroughs that help to explain the super long journey towards the atomic bomb. So just a few examples, not all of them right, but in 1895, you have the discovery of X-rays. We got this great picture there on the right. This is one of the very first X-rays that was ever done. It was Wilhelm Röntgen's, that's his wife's hand. So you can see her bones, you can see her wedding ring. Really big deal when they figure out X-rays. 1896, you have the discovery of radioactivity. It's totally by accident. Guy ruins some negative plates from photography and is like, ooh, there's something going on. And then, of course, raise your hand if you've heard of either Pierre or Marie Curie. Madame Curie, yeah, I don't know if you know much about her, but this is where Pierre and Marie come in as well. They're doing their thing in the 1890s, and they discover the radioactive elements of polonium and radium. It's actually Marie Curie who comes up with the term radioactivity, which is pretty cool. She coins that term in 1898. So there's all sorts of super important stuff going on in the 1890s with radiation, okay? So we're gonna put a pin in that for just a minute. Here you have Marie Curie in her lab, just sort of doing her thing. I honestly don't know what she's doing, but she's in her lab doing something with radiation. By the 1910s and 1920s, doctors are regularly using radium and radioactive materials in their practices across the world, but also in the United States. And the most legitimate uses are in cancer treatment. That's probably not a surprise. We still use radiation and radioactivity in our treatments today, right? Radiation therapies. But that's not how most doctors were using radiation. They were also putting it in water bottles and heating pads. So if you have a sore back, just put a little radium on it. Like, plot twist here, that's bad, okay? This is a really bad thing. But they're gonna fill it heating pads. They're going to incorporate radium into the spa treatments. If you want that nice glow, just irradiate yourself. They are going to prescribe it for rheumatism. Like if you have achy joints, it is both a cause and a solution there. They are also going to use radium to treat impotence and constipation. I don't think I need to describe how they do that, okay? Just let your imaginations go to the worst possible place. And that's what they're doing. On top of that, they are adding radium to toothpaste. They believe that that's the way to get your pearly whites actually pearling white, in particular glowing. If you want the glow to your pearly whites, add the radium. They're also baking it into chocolate. Absolutely, the best, the most expensive chocolates incorporated some radium. Here you have some glasses. Now, they did come with a warning label, do not open eyes while wearing them. I honestly don't know if that would have made a difference. You're wearing radium lenses, but they incorporated into the lenses. And then here is the Revigorator water jar, which is a radium-lined water bottle that was marketed as curing all of your possible aches and ills. So I know we have a lot of colds and rhinoviruses going around right now. You might consider buying a Revigorator water jar on eBay. But they go for several tens of thousands of dollars because they're now collectibles. So suffice it to say, the risks of radioactivity are not super well understood, right? Even in the medical community, people are making some choices that in hindsight are a little, what is it, this generation says, sus? They're a little sus. They're a little suspicious. So just a few examples of sort of a lack of understanding. Have any of you heard of Henri Becquerel? Any science people in the room? That's okay. So Henri Becquerel is the man who discovered radioactivity in 1896. He is literally the discoverer of radioactivity. He burns himself carrying around radium in his vest pocket. Now, in fairness, it was radium that Marie Curie had used, and he was like fangirling because it's Marie Curie. So he was carrying the radium around in his vest, but he literally burned himself. Even more famous and more tragic is the story of the Radium Girls. You may know them. There was a movie that came out recently with Joey King. But the Radium Girls, they were girls, women, young women who worked for the U.S. Radium Corporation in the 1910s and 1920s. It was their job famously to paint dials for, that's not where my watch is, for here, for wrist watches, for airplane dials, and for clocks. And they would paint them with these glow-in-the-dark paints because that's what you want. You want glow-in-the-dark dials. That was the fad. If you wanted to, what's the other word y'all use? Drip? If you wanted to drip, if you wanted to slay, then you had to have your glow-in-the-dark watch, right? I know, I'm not going to make any more terrible references to slang I don't understand. But, like, that is the definition of style. You had to have the glow-in-the-dark watch, and so it was the job of these women to paint that on there. The problem is their bosses had said the best way to maintain a fine tip and write those numbers is to lick your paintbrushes. They even had a motto, lip, dip, paint. It's kind of catchy. Lip, dip, paint. So you lick it on your lip, you dip it in the paint, and then you paint, and then you lick it again. Now, these Radium Girls are not idiots. They went to the Radium Corporation and are like, are we going to get sick from this? And their bosses were like, no, you're safe. That's not exactly what happens. Many of them, they fall sick, they suffer horrendously. Many of them die from radiation poisoning. They eventually sue and eventually win. It's too late for many of the girls. Here's a great quote up here from Deborah Bloom, who wrote about it in the Poisoner's Handbook. And this is a true story. There was one woman who the dentist went to pull a tooth, and he pulled her entire jaw out when he did it. Their legs broke underneath them. Their spines collapsed. We really don't want our factory workers to be the guinea pigs for discovery. Oops is never good occupational health policy. But that's what was going on. Yet at the same time, look, you have this advertisement, Radium and Beauty. And check this out, our new Radium Permanent Wave Beauty. Anyone ever gotten a perm? Imagine doing that with radium. So again, lots of interest, not lots of understanding, okay? So fast forward a little bit to World War II, right? And the onset of World War II is going to lead to the rapid militarization of nuclear research. Why? Because it's war, right? Everybody, even before the war begins, these different nation states who are militarizing, Germany in particular, but different nation states are looking for a proverbial leg up, because the 1920s, if you're in a 1302 class, you've heard this today and yesterday in my case, but the 1920s, it's an age of isolationism, right? But also militarism. And so these different countries, they're looking for a proverbial leg up. And by the 1920s, 1930s, scientists know that atoms store a lot of energy. They have figured that out. I'm not going to give you all the names, right? But you're probably familiar with some of them. So they know atoms store energy. The question is, can you tap it? Can you tap that energy and do something with it? And so the result of this interest is that in the 1920s and in the 1930s, scientists, they begin bombarding atoms and elements, bombarding them with subatomic particles like neutrons. And the whole point is to figure out, can we induce radioactivity? That's the question. Can we artificially induce radioactivity? Also, they want to learn about the structure of atoms. But really what they're trying to do is figure out if they can produce radioactivity. Now, to be clear, no one is really thinking about nuclear bombs at this point. I mean, some people are writing about it. You could produce an explosion, but they're not really worried about it being big on the level of a bomb, because there's so little radium on the earth that it would be like a little, you'll ever throw those poppers on the 4th of July that are like this big and it's pew, 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 and you're like, ooh, yeah. It's like that level. That's what you can produce with all of the existent radium in the world at this time. So they're not worried about a bomb. They're not thinking that, but this is where it leads. Why? Because they accidentally discovered nuclear fission. It's a total accident. It is an absolute accident, because through that experimentation where they are bombarding elements, they discover fission. So in case you don't know, nuclear fission is the subdivision of an atom's nucleus. I have a little helpful, what is this called? Image? I have this helpful image up here where you can see you start with a nucleus, you bombard it with a neutron. Actually, slower is better if you want to sustain a chain reaction, which is key to building a bomb. They figure that out later. But you bombard the nucleus, it begins to split, it eventually splits, and in the process, it creates a burst of energy. And ideally, if you're talking atomic bombs, that burst of energy propels additional neutrons into additional nuclei that creates the chain reaction that is the basis of these atomic bombs. So, subdivision of an atom's nucleus into smaller, you might say, daughter nuclei, and it releases a tremendous burst of energy, and like I said, that's the first step. That's the first step towards making a bomb, and we discover it totally on accident. Not we, not me, scientists discover it on accident. Specifically this dude right here. His name is Enrico Fermi, and in 1934, He's the one who induces fission in uranium. Now, we might as well put a pin in this for about 30 seconds to introduce a little pop culture. How many of you know who this guy is right here? This should be pretty much every hand. So let's get a little interaction. On the count of 3, tell me his name. 1, 2, 3.
Einstein.
Yes, I hope and think everyone said Albert Einstein, right? He of the E equals mc squared equation, right? How many of you have heard of that equation? E equals mc squared, yeah. Well, that equation, put super simply, is all about the equivalence of mass and energy. What that means in super simple historian talk is that mass and energy are basically 2 sides of the same thing. That they can be changed into each other because they're just different forms of the same thing. And Einstein wrote this super famous equation. He's not the only one working on it, to be clear, but he's credited with it. And he writes this equation in 1905. He doesn't work on the atomic bomb, but this equation helps explain that release of energy. In nuclear fission, when you have that big release of energy, initially they don't expect it, and then Fermi and others are like, oh yeah, dude, E equals mc squared. Not in so many words. And then here's the famous tongue sticking out picture, just because, right? He really did this. It's not made up. So getting back to Fermi. The scientific community, at first, they have no idea what's happened with his experiments. They don't realize he has induced fission. They don't appreciate the significance. They're like, did we create something new? Did we change uranium? Did we just break nature? They have no idea. And so other scientists try to duplicate his experiment, right? Let's see what happened. Let's see if we can understand it. And you have a group of scientists in particular who begin conducting these same experiments in Berlin, in Germany. And they duplicate the experience and they figure out what happened. I want to give you their names just because there's a great moment here for us to learn about a lost woman of science. So the 3 figures here, you've got Otto Hahn, this is him right here. You've got Lise Meitner, this is her. And we got Fritz Strassmann. I don't have a picture of Fritz. He's not in any of the pictures. I don't know why. I'm really sorry. But Strassmann, Hahn, and Meitner. They are the ones bombarding elements. They figure out what's happening. It's a super big deal. For their collective efforts, Otto Hahn gets a Nobel Prize in 1944. And just Otto Hahn. He doesn't get to collect it in 1944 because there's this little, World War going on, right, that is distracting people, creating difficulties with travel, but he will collect it eventually, and his discovery is so important that in 1944 he gets a Nobel for the discovery of nuclear fission. Why does Strauss not get one? I have no idea. I have looked this up incessantly, and the only thing I can find is other sources going, we don't know. I can guess as to why Lise Meitner did not get credit. She was a Jewish woman. She was a Jewish physicist living in Nazi Germany. And she is one of the very last Jewish scientists to leave Nazi Germany. Because she was Austrian, so she had Austrian citizenship, so she was exempt from some Nazi laws targeting German Jews for a while. By some accounts, she's the last Jewish scientist, male or female, to leave. But in any case, she's actually the one that figured out what was going on with uranium. Because after she fled Nazi Berlin, Otto Hahn and Fritz Strassmann continued the experiments, and they were like, what? And so they sent their notes to Lise Meitner, who's like, oh, I got this. And she's actually the one that figured out that uranium was splitting into smaller daughter nuclei that included radioactive isotopes. But again, she doesn't get credit. Later on, she will get an award that she shares with Otto Hahn. And Otto Hahn, for his part, does split the Nobel Prize money. She feels very conflicted about not getting credit. It leads to this big moment of tension between them. But in any case, here's Hahn and Meitner. And after that discovery of nuclear fission in 1938, or rather the confirmation of nuclear fission in 1938, what's going to happen is the Nazi leaders immediately were like, we can weaponize this. And so immediately, German scientists, I'm going to say join a uranium club. It's kind of being voluntold. They're kind of voluntold into a uranium club whose sole purpose is to investigate military applications. And that is where the world stood in the months leading up to World War II. We are on the precipice of something humongous with nuclear research. So, about these Germans and these bombs. The Germans, they do build a nuclear reactor. It is the B8 or BVIII nuclear reactor. They never build an atomic bomb. Consensus is they likely never got close, but there are some conspiratorialists out there who believe the Nazis were just a couple days away, so use the Google and I guess take your pick, but most people would say the Nazis don't get close, but US officials thought they were close. And I have these photos up here. This is a picture of the B8 heavy water nuclear reactor. It was taken in 1945. And the whole point is you suspend, these are little uranium cubes. And the idea is you suspend that in water to help with the production of heat during a reaction. And as the Allies are advancing into Germany, you might know that happens, right, in the spring of 1945. The German scientists are going to bury these cubes in a field. So here you have a picture of a team uncovering cubes. Here's a better picture. It's beautiful, isn't it? At least the lighting, I don't know. The cube's not, but the lighting in the cube. One of these cubes just appeared on a scientist's doorstep one day, literally in the mail, with a little piece of paper wrapped around it. This is a uranium cube from Nazi Germany. And he was like, what? So there were 664 of these cubes in the B8 reactor. There were 1,000 additional cubes in other reactors. Had the Nazis pulled their cubes, they might have actually succeeded in their efforts. But there's 664 identical cubes in that reactor. 650 of these cubes have not been located.
That's good.
Yeah. Take that for what you will. The consensus is some of them disappeared into Allied families on their way back to the war, and some people believe others were incorporated into the U.S. nuclear research program. I got no idea, but 14 are accounted for. I don't know. I don't know. That makes me a little nervous. But in any case, that is where, sorry, that's a wrong dude. That's Cillian Murphy. There we go. So, U.S. officials, though, we don't know how close the Germans are. We still don't know today, okay? And so U.S. officials freak out. They begin to freak out because the Germans are at the forefront of nuclear research. If anyone can do it, it's them. It is them, and that motivates our own work. Because it doesn't matter that the Germans aren't actually close realistically, perception matters. We all know that, right? Sometimes perception matters more than almost anything. And so, how do we know what's going on in Nazi Germany, by the way? Because of Albert Einstein, largely. He's going to write a very famous letter in 1939 on the advice of another physicist. He sends it to FDR, president at the time, and is like, yo, FDR, first off, there's been this recent scientific discovery, and you can create a nuclear reaction that sets off a big explosion. Also, secondly, the Germans are working on this. He is the one who alerts FDR. He later regrets sending this letter when the Germans don't build a bomb and the Americans do. Einstein is like, oh my gosh, I had a role in propelling this forward. But this letter is really the reason why you see the beginnings of a nuclear program in 1939 that culminates in the Manhattan Project, right, formally in 1942. You've undoubtedly heard of this dude, J. Robert Oppenheimer, who helps to head up the Manhattan Project. Through this work, U.S. officials test the first ever atomic bomb on July 16, 1945 in New Mexico. Fun little fact, this little piece of green glass is called trinitite. It was created by the explosion of the Trinity test, so it is literally sand that is fused from the heat and the power of the atomic bomb. And then, of course, following that test, we deployed 2 atomic bombs. We dropped 2 atomic bombs in Japan, right, in Hiroshima and Nagasaki during the war. And so that is my, I guess, not so brief little introduction there to the science of it. And I am going to put on this video. It's only 2 minutes. while I introduce the next section. So this is a video up to 2019 of every nuclear device that has ever been tested. The number is above 2,000, by the way. We account for more than half of that. Check out what happens in the 1950s with the increasing number of nations who participate, with the increasing size of the circles, which tell you about the strength of the bombs to some extent. Over here, this is Nevada. We test more than 900 nuclear bombs in Nevada. By the time you get to 1962, look at the total number of tests the United States has conducted. Look at how quickly the Soviet Union and the United States are outpacing literally everybody else. Check out the Soviet Union in the 1960s. Cuban Missile Crisis leads to a dramatic escalation in the early 1960s. Now we're getting into the 1970s. You have new players entering the picture. I hate to say this, we're nearing my birth year, 1982. The United States will continue conducting nuclear tests until 1992. 975, 983, 1,002, 1,020. 1987, 1988, and like I said, the final test in the United States is in September 1992. I've lost my mouse. Where's my mouse? There it is. There's my mouse. Okay, also, can we appreciate that like 1970s like synth just sort of foreboding music that they added to that? I don't know if that was powerful for you, but I couldn't sleep for a couple of days after I saw that video because I really didn't have an appreciation for just how many bombs had been tested. I should have. But that is pretty amazing. And the United States in particular has conducted more than 1,000 nuclear tests from July 1945 to September 1992. To put this into a little bit of perspective, because I just don't really see the shock faces that I feel on the inside. So to put that into perspective, from July 16th to September 23rd, 92, there are roughly 17,200 days that pass between our first and our last detonation. 17,000 days on average. We conduct more than 1,000 nuclear tests, which means on average during this period, we are dropping a nuclear bomb every 17 days. Every 17 days. And that's just us. That doesn't count everybody else. So let's talk now super briefly about the geography of testing. You already figured this out a little bit from the video if you were watching. But dozens of tests are going to take place in what is called the Pacific Proving Grounds. That's basically the Marshall Islands, Bikini Atoll, if you're ever seen SpongeBob, right? Bikini Bottom is named for Bikini Atoll, supposedly. The bikini swimsuit thing is named for Bikini Atoll. You got a pop culture element. But the Pacific Proving Grounds, you've got these idyllic landscapes and then just these horrifyingly destructive tests. And in case you don't know where the Marshall Islands are, here's Bikini Atoll, so it's literally a couple of strings of atolls. Here's the Marshall Islands down here, right? So South Pacific. So we do a good number of tests in the South Pacific. We also conduct some tests in Mississippi, in Alaska, and in Colorado. They're all underground tests, so people don't know about them. But we test outside of the Pacific Proving Grounds. The vast majority of our tests, however, are in Nevada, more than 90%. We just blow Nevada to bits. More than 900 nuclear tests are conducted in Nevada. Why? I'm so sorry if you're from Nevada, but the truth is they just don't really see as much population, we'll say. I was gonna say value. That was just maybe a little too harsh. They picked somewhere where they're like, there's not a lot of people. It's pretty bare. It's pretty arid. It's pretty empty. And it's a beautiful place, okay? I love Nevada. And there's value to that landscape that is defied by its kind of dry nature, okay? In fact, it's very ecologically vulnerable. But I know, I have to say something. But most of these tests, 90%, take place in that Nevada desert. And again, largely because it is remote. And that's because after the Trinity test in New Mexico, scientists are like, oh wow, fallout's a bigger problem than we thought. We need to move these tests away from people, at least 150 miles, which I don't know if you know this, there's this thing called wind that sometimes blows fallout around. And so sometimes 150 miles wasn't far enough. There are some scholars who estimate that radioactive fallout from the New Mexico Trinity test was dispersed as far away as Canada. That is debated by other scholars, but certainly the point holds that the impact of these tests is not limited to 150 miles, right, around the epicenter. Despite those dangers, a thriving atomic tourism program emerges in Las Vegas. Straight up, these are all atomic bombs. She is posing, I think she was like Miss Las Vegas or something, but she's posing, bomb, 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 bomb. Also, it's not morning, it's the middle of the night.
Nice.
It just looks morning because bomb, 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 bomb. And so you really could pay to take a bus to see genuine atoms split to smithereens. I don't even think you had to sign a waiver because they don't know about that kind of stuff yet. Also, not one to miss opportunities. Most of the clubs and casinos, they also get in on the action and they begin selling atomic cocktails. I don't know what was in them, but they were just atomic themed. So getting into the tests a little bit, right, and what they looked like, the very first peacetime nuclear test in the United States involves something called Operation Crossroads. And it was in July 1946. Why is it called Crossroads? Because one of the high-ranking U.S. officials was like, dang, we're at a crossroads where we don't know if the Navy and Army are going to be valuable in a nuclear age. And he's like, that's a good name. I'm not even kidding. And so they named this Operation Crossroads. But Operation Crossroads, it is held at that Bikini Atoll. Famously, the residents, 167 of the Bikini Atoll, are evacuated. That's one reason why they chose the Marshall Islands. They were away from established shipping lanes. At the time, they were under U.S. control at the end of the war, and they were lightly populated. So in theory, you can remove the existing population somewhere safe. I'm using that in quotation marks for those of you who are not looking up, which is cool. Keep writing. But the 167 residents of Bikini Atoll, they are evacuated on the promise they will be returned soon. Plot twist, they are not returned. Well, they are returned briefly, they get sick, and they are removed once again. Bikini Atoll is still not habitable today. But at the same time that 167 I just spoiled that. At the same time, I got too into my finger. At the same time that 167 residents of the Bikini Atoll are evacuated, 42,000 service members are brought in. 42,000 service members are brought in. International press is brought in. The Soviets are there watching. It's because we want to impress them. In fact, the Soviet ambassador goes, this wasn't very much, and leaves. We invite the senators, we invite congressmen. This is a public thing. This is not secret. Manhattan Project had been secret. This is not. This is about putting out a very public message. So this is one of the cards right here for Lieutenant J.G. Lee, who was at the Bikini Atoll. It's the only surviving thing he donated to the museum for some reason, but it's still a little radioactive, by the way. But in any case, they bring all these servicemen. They also anchor a fleet of 95 ships inside the Bikini Atoll. The ships are of various sizes. Some of them are Japanese, some are German, some are American. And the whole point is we're going to drop a bomb and see what happens. Now, there's no people on these ships, okay? but they do load them up with animals. Thousands and thousands of little goats and little rats and little mices and even some guinea pigs. I don't know, like literal guinea pigs, like literal guinea pigs. And the point is to see, one, what happens to the ships, and two, what happens to the animals. I didn't want to put the pictures up here because I just am a mom and I have a soft heart nowadays and I'll cry, okay? But suffice it to say the animals don't do well. Within less than a year, every single animal on these boats, save one pig, is dead. And if you Google the swimming pig of Bikini Atoll, it'll tell you the story of that pig who, I don't know, no one knows how, who miraculously survived this, okay? But otherwise, all the other animals are either killed in the test or die within a year afterwards. But in any case, they dropped 2 devices in this first peacetime test. The first one, it's dropped by a bomber, and it totally misses the target. I mean, it is so far off, and so, like, there's no damage. They get right back on the ships, and they're like, oh, wow, that was anticlimactic. And so the second test, they're like, underwater detonation. It creates a column of water 500 feet high, and it creates tidal waves 90 feet high. Suffice it to say, it's a much bigger deal. The Baker test, the second test compared to the first test. Based on the reports, Bikini Atoll is so radioactive, you can't set foot on it for a week after this test. And this was in the middle of the lagoon. It wasn't even on the actual atoll. Also, based on these tests, all of the servicemen would have died had they been on the ships. I guess this is as good a time as any to tell you that supposedly, okay, the sources are in contradiction. Some of you history majors in particular have had some problems maybe where you've been papers or working on, or you're in classes where you're like, the sources are in contradiction, what do I do? So I'm just going to tell you the sources are in contradiction here, but supposedly some of the pigs were dressed in uniform and slathered in sunscreen to make these tests more authentic. I take that for what you will, but there's some valid sources suggesting that happened. I don't know if it brought any data, okay? But in any case, you got the heat, the progressive blast. Medical directors are so appalled at what happens with the second test, they turn around and create the Naval Radiological Defense Laboratory to handle decontamination of further tests, because they're obviously not going to stop testing. That is just the first peacetime test. You can see here, this is from the National World War II Museum. This is the Baker test. It is not in the immediate moments, but can you see the teeny tiny ships? I need a banana for scale, right? Like, to give you an idea. Y'all know that banana's for scale? Anyway, y'all don't get that. Okay, but teeny tiny boats. I don't know if y'all can appreciate that from how far back some of you are. So that's the first peacetime test. The success of Operation Crossroads is going to lead to additional nuclear testing. And what you're going to see in particular is this is the era of the Cold War, right? That begins basically at the end of World War II, continues into the 1980s. And the escalation of tensions between the Soviet Union and the United States puts ever more pressure on weapons developers in the United States to build bigger bombs. And it creates this cycle where the Soviets and the Americans, who are totally spying on each other, are just going to try to continually outdo each other. And so in that context, Operation Ranger, and I put the GIF in here for you just for funsies, but Operation Ranger is the first test at the Nevada site. That is in 1951. By this point, the Soviets have tested their first bomb. That was in 1949 in modern-day Kazakhstan. Also, by 1951, the Korean War has begun. We are beginning to fear that this proxy war in Korea might lead to hot fighting, not just a Cold War, right? And so, again, you're going to see this pressure to produce bigger, better weapons. Later that same year, so it's less than half a year later, you're going to have another series of tests. And when I say operation, that doesn't mean there's one deployment. Operation Ranger includes 5 different atomic bombs that are all part of the single operation. Operation Buster Jangle later that year has 7 devices that they launch on successive days or in successive weeks. Operation Buster Jangle is the very first time you have troop maneuvers. And the whole point is here, and this is a quote, we need to cure our troops of their mythological fear of radiation. And so they send some troops out 5 minutes after the blast, some troops out 30 minutes after the blast, some troops out a few hours after the blast, and it's also obviously about gathering data. Now, most of these troop movements in this and in other tests are voluntary, but if you know anything about military hierarchy, voluntary operations don't always feel voluntary. So there's been a lot of ethical discussion since then. But in any case, you have the first troop movements at Operation Buster Jangle. Why? Because by this point, we're afraid we're getting involved in a land war. At least there's the potential for a land war with the Soviets. And then Operation Ivy is the first test involving a hydrogen bomb. That was held at Eniwetok Atoll, which is right next to Bikini Atoll. It's in the Marshall Islands. The hydrogen bombs dropped at Operation Ivy, in particular, Ivy Mike, this is Ivy Mike right there, it was 500 times more powerful than either of the bombs dropped in Japan. 500 times more powerful than either of the bombs dropped in Japan. The whole point was to create, as my oldest would call it, a super nuke. The whole point was to create a super nuke. And if you read the documents, it will say things, I'm paraphrasing, but they want to create a bomb that is as superior to the atomic bomb as the atomic bomb was to conventional bombs. And they basically did just that. In addition to all of that, here is a picture of the Ugalab Island. This is in the Eniwetok Atoll. I should say it's what used to be the island before the detonation of Ivy Mike. If you know how to read these types of aerial maps and sonar maps and even topographic maps, then you have a little bit of a heads up here. But the lighter color means shallower, right? The darker color is more usually attributed to deep ocean. It means deeper. This all used to be the same color, and this used to be an atoll. Can y'all see that massive crater that went miles deep? They are literally changing the landscape here. You have on a lighter side additional operations at the Nevada site that involve the construction of a mannequin city. If you've seen, I like to pretend there's only 3, but if you've seen the 4th Indiana Jones movie, The Kingdom of the Crystal Skull, and he's running through the town and then he gets in that refrigerator and gets blown away and he walks away from this. Anyway, I love Indy, but that they're basing that on something that actually happened. They construct these towns to see what happens. I don't know what would have happened to that guy. I guess he would be fine. So, the success of all these operations, people are already getting sick, by the way. Workers are already getting sick. But the success of these operations sets the stage for Castle Bravo, which is the focus today. I'm not actually spending any more time on it than any of the other tests because I just can't, but in theory, it's like the anchor for this, right? Operation Castle was at Bikini Atoll. These tests are not the first hydrogen bombs, right? That was Ivy Mike that we just saw. But the difference here with Castle Bravo and Operation Castle is they want a hydrogen bomb that can be deliverable. That means it's small enough that you can drop it from a plane. You can actually deploy it in combat. And that's what they are testing here with Castle Bravo. The problem is officials grossly underestimate the bomb. The Bravo test overperforms, if you want to put it another way. They anticipate a yield of 5 to 6 megatons. I don't know if that means a lot to you, but a single megaton is more than like 1,000 pounds of TNT. So these are pretty big, okay? We're still talking 500 times larger than anything going on in Hiroshima or Nagasaki, and that's not to discount what happened in Hiroshima and Nagasaki. That's to give you an idea of the scale. What happens instead is, this is a 15-ton megaton device. It creates a fireball 10 miles wide. I can't even comprehend that, okay? It creates a fireball 10 miles wide. It is 1,000 times more powerful than either of the bombs dropped in Japan in 1945. And the consequences of this miscalculation are huge. It vaporizes 3 islands. Vaporizes 3 islands. In 2017, a Stanford biologist visited the site to get an idea of how the local soils were impacted. He estimated, I don't know why he chose this, okay, but he estimated that the blast hurled the equivalent of 216 Empire State Buildings worth of dirt into the air. Again, we need something for scale. Bananas, kittens, tons, I don't know, okay? But Empire State Building is big. 216 of those would be big. And that much dirt was hurled into the air. Radioactive fallout dusted servicemen. It dusted nearby atolls on the Rongelap Atoll. Inhabitants didn't know about the test. They didn't know what fallout was. It fell like snow and they were eating it. They were playing in it. And many of them got sick. You also have a crew, you might have heard of the Fukaru Mao. I probably said that very wrongly. It's called the Lucky Dragon, okay? A Japanese fishing vessel dusted with fallout as well. Initially, we don't know they've been dusted. We don't say anything. They go back to port in Japan. They start getting sick. It creates an international incident. And so the Castle Bravo test, it leads to big-time international scrutiny and to change. Because the fallout reaches India, it reaches Southeast Asia. Most estimates say it reaches Europe as well and Africa, and potentially the west coast of the Americas. It is big time. The atolls and coral reefs in the entire South Pacific Ocean still measure high carbon-14 data from this test. And so in the immediate aftermath, you have the very, very, very first calls for a ban on nuclear testing. They come out of India. They come out of India. Specifically, the Prime Minister is Jawaharlal Nehru. And he is the first statesman anywhere to call for a ban. It's going to take a while for the ban to happen because things are going to escalate in the Cold War. You've got the Cuban Missile Crisis in 1962, but that kind of scares Soviet American officials enough that in 1963, you will have a limited ban on nuclear testing. They do not ban underground testing, which is why all the tests move underground. But they do ban underwater testing, atmospheric testing, and space testing. And if you're wondering if I mean space is in space, I mean space. We nuked space.
I'm sorry? What?
Yeah, we nuked space. Come on, of course we did. 1962, right before that partial ban, we decided that we were also talking about putting copper needles in space to like measure various things. You have some pretty extraordinary ideas, okay, at this time that are born out of fear over what the Russians, the Soviets might be doing. And so we're afraid that the Soviets might nuke space, so we nuke space first to study the effects of what might happen. And I know this doesn't look like much. It could be a dandelion, okay? But this is a picture of space being nuked, okay? It's a big deal. So we nuked space. It's called Starfish Prime. We exploded it about 250 miles above Johnston Island and created the first space weather event that was anthropogenic. We knocked out electromagnet and communication networks for like thousands of miles. People in Hawaii were like, what? Because they lost all communications, most of their power as well. But they also gathered to watch it. Apparently it was really pretty. I don't know. So we're even nuking space. So what I want to do now in the time I have left, because I've talked for about 49 minutes, 47 if we count Dr. Huntley's introduction, and I don't want to keep you too long, even though I have an hour and a half, and I'm going to use every second. But I do want to talk a little bit about some of the ecological consequences, right? And at the end, if we have time, I'll show you a map where you can like detonate different bombs anywhere in the world, and if we have time, we'll detonate some bombs in San Angelo. Just to sort of see the impact. Dr. Huntley wasn't impressed earlier. She was like, that's not as bad as I thought it'd be. I'm sorry, I need to stop calling her out. You were wonderful, thank you. Okay, but if we have time, we'll play with the website because that's what the newspapers were publishing every day during the Cold War. Hey, if you live here, you'll be incinerated immediately. If you live here, you'll just die from burns. If you live here, you'll probably live 20 years but have cancer. They were publishing maps like that nonstop. So talking about the ecological cost, we're going to start with the human cost. Sometimes in my environmental history classes, and we've talked about this in my enviro class this semester, but sometimes students are like, why are we talking about human health? We should be talking about the environment, but like humans are part of the environment, right? We're connected to the natural world, and there is a huge human cost to nuclear development, not just when you're detonating the bombs like what happened in 1945. There is a public health cost along the entire way. One great example, sad, but great example, is mining the ores. Mining on the Colorado Plateau is a really, really important example because even before we're building bombs, we're mining uranium on the Colorado Plateau. We have been mining uranium in Colorado since 1872. Sorry, I just like bit the microphone. We have been mining uranium since the 1870s. At first, we're like, what is this? And we just toss it aside. It doesn't really have any value. But pretty quickly, we figure out there is value, and by 1939, there is big-time mining enterprises here. These mines extract uranium core, nearby mills crush it into powder. The powder is yellow, and so if you've ever heard yellow cake to describe a bomb, like the Get Smart movie, right, talked about it with Steve Carell, they're known as yellow cake towns because yellow cake was the name of that powder. And these towns, they would look like something out of a really oddly lit sci-fi horror movie because they would just be completely dusted in yellow. And as you can imagine, people living in and near these towns face tremendous health challenges. In fact, incidences of cancer are, depending on which source you use, somewhere between 10 to 50 times higher in the Colorado Plateau than you would expect in an average population. Also, we know to be careful with uranium because they have been mining it in Europe much longer than we have here. And one of the sad things here is officials dismiss warnings that like super simple ventilation measures could have saved a lot of lives. And they just, for reasons that are debated, are going to ignore those warnings. In particular, a lot of the mine workers are Navajo because a lot of the mines are located on Navajo reservations. A 1983 court case found that these Navajo miners had been exposed to doses higher than what was received as a result of the atomic bomb explosion in Japan. They were then told they had no recourse to sue because you can't sue the United States. But the judge did go on to say that, quote, this was a tragedy of the nuclear age. So to this day, there are court cases where these miners are trying to get some sort of reparation, as are people who live, they're called downwinders, who live downwind of this. So you've got health costs to mining it. You also have health costs for the troops. They're called atomic veterans. We already talked about how sometimes troops are going to just be sent out to desensitize them. But there are other experiments as well. For example, you have flash blindness experiments where the troops are told to watch the bombs and they say, cover one eye, watch the bomb, and we're going to measure if there's any damage to your corneas after exposure. And then they move you closer and they repeat the experiment. You also have protective clothing, right? But you got to figure out how well your protective clothing works. And so they will send troops out there to test the effectiveness. You have to figure out how to decontaminate planes and ships. And I'm not trying to like throw the military under the bus here. I'm not trying to make moral judgments at all in this. They're learning as they go, but they make some big time mistakes. And so, for example, to test decontamination, they will tell some people to clean ships and airplanes with their open hands and others to wear gloves. And then you measure whether or not the people without gloves get sicker. They also have people fly through mushroom clouds to collect data and figure out if anyone's getting sick. So you have an entire 20 to 30 years where active duty military personnel are essentially being experimented on. Again, sometimes it's voluntary, sometimes it's not. And there's a lot of court cases still to this day for these atomic veterans or their family members who are trying to suss out sort of what do you do about this fact. On top of all of that, building the bomb comes with ecological health costs. It doesn't take more than a year before people in the Manhattan Project start getting sick. And the doctors figure that out. They're uncovering issues in routine medical checks because they're constantly monitoring the health of these people to make sure they stay healthy. The doctors go to Manhattan Project officials and are like, what do we do? And Manhattan Project officials are like, you don't say anything. Now, some doctors will say something, and some Manhattan Project officials are like, you gotta say something if somebody is sick. But you have an obvious ethical dilemma, right? Where you, in the name of national security, have legitimate needs about protecting American interests that you're balancing with the need to protect these men, and the doctors are employees of the lab, as are the men working on it. And so some of the doctors become, and some of the Manhattan Project officials become concerned enough about what they call, quote, the appearance of the Buchenwald touch. And that's a reference to the Holocaust and some of the experimentation that went on. So the Manhattan Project officials, to quote one of the leaders, he said, it's not very long since we got through trying Germans for doing the exact same thing, Nuremberg. And so you're going to see by 1952, they're going to adapt the Nuremberg Code that had been drawn up in 1947, drawn up in Germany. But again, there's a lot of conflict between doctors and workers over how much do you say? And then, of course, testing the bombs, right? People living downwind. People living downwind. And so before we move on from this public health for just a couple minutes of ecological health consequences, I'll say that some of this probably hits closer to home than you might realize. Raise your hand if you've heard of the city Amarillo. It's the whole song, Amarillo by morning. Yeah. Anyway, how many of you have heard of the Pantex plant? Yeah, the Pantex plant is a nuclear assembly and disassembly plant in Amarillo, Texas. It is the only at this point nuclear assembly and disassembly plant in the United States. And in fact, they have more than 200,000 cores that are sitting in Pantex that they don't know what to do with. Because by international treaties, we're limited to a certain number of nuclear bombs, and we want to make sure they're like the highest tech, so we keep disassembling old bombs and building new ones. And Pantex literally can't take any more. So this hits home, okay? But let's finish this up, if I can find this, by talking about some of the ecological costs. So obviously, nuclear weapons are incredibly destructive. And the footprint of that is not limited to the Nevada deserts or the Pacific atolls. Literally every single stage is polluting. Nearly every single stage of development has an ecological cost. So mining and extracting the ores, ecological cost. Waste disposal, my gosh, big time cost. Did y'all know that there's a court case right now in Texas about whether or not a third party can bury nuclear waste a few counties over? In Andrews County, specifically, let me make sure I get the numbers right for you here, because it's kind of a lot. Specifically, they want to bury 5,000 metric tons of fuel and 230 tons of solid waste in Andrews County. In case you're not up on metric tons and what that means, that's the equivalent of 11 million pounds of spent fuel and 507,000 pounds of solid waste. And it's right now being debated in Texas courts about whether they can bury that a few counties over. So again, there's relevance to this day. But getting back to the footprint, you've got waste disposal, you've got disasters, you've got intentional releases, you've got radiation, you've got fallout. And something to consider is that this footprint is humongous. And it's not limited to a certain year, right? For example, the fallout falls on the ground. It can leach into the groundwater. Currently, Nevada has more than 1.7 trillion gallons of groundwater that are unusable because they've been irradiated. I don't know if you know this, but Nevada's dry. It's called a desert. I consider it a desert. Have you been there? It's pretty dry. They could use that water. That is more than they are allowed to draw out of the Colorado River for 5 years. We also, our backup water supply, plug your ears if you're squeamish, our backup water supply in San Angelo is the Hickory Aquifer, which has such high radiation levels, it's not potable. This is relevant today. But here you see the seafloor at Bikini Atoll. It's supposed to be more or less flat. These are craters created by the dozens of tests. Here you have Lake Karacha. This is considered the most polluted lake in the world. It's in Russia. Well, it was part of the Soviet program, I should say. And it was connected to the Techa River. It was a Soviet facility. Supposedly, this water is so polluted from nuclear weapons development that being around it for an hour will kill you. How do you verify that? I don't know, right? So I cannot verify that, but that's what the scientists say. So problems with waste disposal. The United States has 65 million gallons of liquid waste buried. And we have more to bury. You also have intentional releases, but I do want to end on sort of a high note. I mean, unless you're the victim, right, of an attack by Gojira or Godzilla. But you do have so much fear, and I don't want to like shade the fear and discount that, but you have so much fear over the Cold War and nuclear technology that it does have, in hindsight, some pretty fun impacts on pop culture. So I don't know if you've heard of the Beast from the Beast from 20,000 Fathoms. It was an American movie, came out in 1953. It is basically Godzilla a year before Godzilla. It's a year before Godzilla, so there's some like debate on who knows what who is doing with these movies, right? But it is a Godzilla-like creature who is a fictional dinosaur, and he's awakened from hibernation by an atomic bomb. Gojira is 1954, Godzilla is 1956. It's a prehistoric beast awakened by an atomic bomb, a hydrogen bomb. He also has radioactive breath. In addition, you got all sorts of movies about big bugs and big people and apparently big cats and shrinking men, all sorts of comic books. Spidey is radioactive. Old school TV show, the theme song is literally Spider-Man, radioactive spider, like it's in the theme song. You got the Hulk, right? You got Astro Boy. So it's absorbed into pop culture. I don't know why we have bikinis named after Bikini Atoll. I do understand these pop cultural references, but clearly I could go way longer. I'm gonna stop. There is a big cost ecologically, a big cost socially, and relevance to this atomic program to this day. And by the way, that little video I showed you that horrified me, and I don't know if it horrified you, it only went to 2019. There's been additional detonations since then.
Oh.
North Korea.
Oh.
Yeah. So this includes the detonations, whether you're talking Soviet Union, United States, Korea, Iran, South Africa supposedly has a detonation in there. It's not been verified, so I didn't include it, that we know about. Okay, so that is the end. Do y'all have any questions?
So with the underground test, how would you make like a facility big enough to contain that? Or do you just like bury it like 20 feet under and see what happens?
That is a great question. Have any of you ever seen Eureka, the TV show? I swear I do more than watch TV, okay? But it doesn't feel that way. If you have, you would partly know the answer. So what they would normally do is build essentially the equivalent of a silo down into the ground. And they could go thousands of feet deep, hundreds of feet deep. Hopefully, if you're testing underground, the device is not on like the scale of an Ivy Mike or a Castle Bravo, just because how are you going to contain something like that? But normally they make it quite wide. It can be hundreds of feet wide, hundreds of yards, and then ideally you just build it deep enough and have a detonation that lasts long enough that it doesn't cause any problems. But with the Mississippi detonations, for example, it caused earthquakes, and you could feel it on the surface. They didn't always warn people, so there's this great PSA, for example, from Mississippi, and there's one from Las Vegas, where it's like children like huddling in their classroom. There used to be like the duck and cover video with the turtle, duck and cover, and it's like that style duck and cover, except there's like this flash in the window and it says, just remember, you may not always know a bomb is being tested until you see the light. And so, I mean, the warnings were not always great, but ideally you're dropping it deep enough, because the United States doesn't withhold information to the same extent that the Soviets do during this period, but in the name of national security, it's not like we're publishing all of this. And so they'd rather not tell people every time they're testing a bomb. So they try as much as possible to bury that. I don't want to sound unpatriotic, but they try not to they try to control it as much as they can, but you can't always control things like this. Yeah. Other questions? Yeah, Daisy.
So you're kind of talking about the USSR. So I'm wondering, how much information do we really have about their stuff? 'Cause I know with the fall of the Soviet Union, a lot of documents and stuff were that person can get access to. So how much do we really know, or is there still stuff that's hidden away or been lost?
Yeah, that's a great question, and the answer sort of depends on how conspiratorial you are. So some people believe that the Soviets tested more bombs, quite a few more bombs than we know about. Now, the thing is, the Tsar Bomba is massive. That is the biggest thing ever tested. It dwarfs even what we do with Castle Bravo, and there's 4 other tests larger than Castle Bravo. That's the 6th biggest in world history. Something like that, those were all atmospheric tests because you'd probably obliterate the Earth's core, right, if you did that underground. And in atmospheric tests, even if you try to hide that, people are going to see. I mean, it's just so big. And so it's likely that the Soviets aren't lying about the number of atmospheric tests unless they're very small. But in terms of underwater tests, in terms of underground tests, that can be easier to hide. And so certainly with the fall of the Soviet Union, we learned a lot about their program. Even Chernobyl was hidden. I mean, that famous disaster. That was even hidden. But in the winds, you have a pickup of radioactive isotopes on wind patterns over in England, and people are like, oh, something happened. And so sometimes just because of the fallout and the ecological consequences, we're like, these reefs are dying, something happened. And so most people would say that there's probably things we don't know about the Soviet nuclear program. Undoubtedly, there's gotta be things we don't know, but that it's not probably on the scale of something like the Tsar Bombas, just because it's so hard to obscure the consequences of something on that scale. But that's purely my guess. I will own that. Other questions? Yeah, Daisy.
So what efforts have been there made? Because obviously, we just talked about all of these awful things that are still left over. What efforts have been made to kind of deal with that? Do we have strategies in place to kind of deal with it? How are we kind of reckoning with what's going on now? How has that changed things from what we've learned from and we're okay, we can't do that anymore.
Yeah, that's a good question. My goal in my Enviro class is to traumatize my students at least once a week. Trash islands, space trash, microplastics in your water. So, this is on par for me. So the real answer is that certainly people have, for example, U.S. officials have tried to work on remediation to some extent. If you've heard of the Superfund program, it is a program run largely through the EPA that tries to remediate not just nuclear weapon sites, but some sites that are associated with, for example, nuclear waste disposal, like Simpson style, where things start to leak. And all of a sudden you have fish with 3 eyes. That happens. There are several parks in the city of Dallas that are built on top of. Yeah, not coincidentally, they tend to be in the poor neighborhoods and neighborhoods with higher minority population numbers. There's a direct correlation there. But you have several parks, yeah, that in some cases are literal Superfund sites that were discarded. So in some cases, you have the government, for example, actually putting money, but the cost, just Hanford is a nuclear facility up in Washington. Let me see if I have the number here. I may not. But just to remediate that one facility is estimated at $667 billion. And that's just one facility. And so you also have individuals who are sort of committed to trying to clean this up on a more grassroots level, but the problem is, like, how do you store this radioactive waste? Its lifespan is literally longer than the steel bins or whatever it is you're putting it in. At one point, the Soviets tried to launch it into space. Some people have dumped it in rivers and oceans. You can immobilize it in a solid form, which is what a lot of people try to do. And then the goal is to just wait until the half-life is such that it's not too radioactive. But no one has really found a great solution. And that is one of the things that the nuclear energy sort of people who want to build more nuclear reactors for peaceful uses, right, nuclear energy, that's one of the things they run up against is opponents to that are like, well, first off, dangers, right, 3 Mile Island style, like meltdown dangers, but also what do you do with any waste? Because you have to change out the liquid after a while. You have to change out the fuel, rather. So there's not a real good approach. Except that there's a lot of talk on, like, for example, one thing you can do socially is for people in Bikini Bottom, for example, you can make reparations. For the atomic veterans, make reparations. That doesn't help necessarily with the ecological cost. You can go plant trees. You can just hope that, you know, the water table is not going to get to the nearby city until 2060, so you're going to be fine. Monitoring is a big part of it, yeah.
Kind of specifically talking about the ecological cost, wouldn't that also, so specifically with goal of visual in space, wouldn't that make it actually a better thing if we're doing a lot of our testing in space?
So that's what some people are going to argue, because they're like, well, you're not going to have as many consequences on oceans, like that's a bad thing to irradiate your oceans, right? You're not going to blow up islands. And so some people are like, hey, we should conduct our tests in space because there's fewer things for it to hurt. The problem is, have y'all heard of the Van Allen belts? Like these electromagnetic fields, they're shaped like donuts around the Earth. And when we set off the Starfish Prime, part of it, the purpose was to see what happened to the Van Allen belts. We were like, what will happen to Earth's magnetic fields if we nuke them? And so the big concern with scientists is that if you nuke space, that's probably the wrong way to put it, if you detonate nukes in space, if you nuke space, that you run the risk of eventually, either chronically or acutely, changing the Earth's electromagnetic fields in a way that could be very devastating for life on Earth. And so it's more a fear of the unknown there than anything else. Yeah. Any other questions? Yeah, Ethan.
The lake in Russia, besides the fact that, you know, there's like a town like 2 blocks away, what, if any, efforts are being made to like repair that?
Oh gosh, I don't know of anything. So this lake is connected to a river that fed directly to the Mayak facility, which built the first bomb for the Soviets. So this is like the heart of the beginnings of their nuclear program. They literally built the first bomb there, and in some cases they were just like dumping stuff in the river. And so the river became so overloaded that it was like moving downstream into the lake anyway, but they just started like directly moving things. Supposedly if you stand on the edge, you can just like, you just pass out and fall in. Again, how do you test that? I don't know. And I will admit that this is not my geographic region of expertise, so there could be something I'm missing here, but I don't know of anything. I don't know of anything except not dumping additional radioactive waste. I know that at least legally is not going on. You never know about what's being dumped illegally, right? But outside of that, I don't know of anything. I mean, certainly people have talked about, let's develop a bacteria that eats radioactivity. And just like they're trying to find bacteria that can eat oil, right? And that's the way to solve oil spills, and actually they have that, right? Put some of the bacteria out, and you can help with the oil spills. And there's some people like, we need something that can eat the radioactivity. That I don't know of anything yet that has been successful. It's not like you can throw baking powder and vinegar in there, which is like my go-to cleaning thing, right? So I don't know, but there could be something. I mean, you've got to think they're studying it though. Yeah. Other questions? Yeah, Daisy?
So I guess kind of earlier, like all the radioactive, all the stuff from like our munitions and the bombs and stuff. But what about like the stuff earlier that was like all of like the irradiated water jug
Yeah.
and stuff? What are we doing with all of that, like leftover things, the watches, everything like that? What do you do with that now? Like they must. I know like Mary Curie, like her notebook is like has to be like in a special like radioactive proof box because it's so much. What are you doing with the rest of that stuff? That's just like going around eBay or something?
Yeah, basically. Also, I didn't mean to have Einstein side-eyeing himself here in this picture. I just realized as I was going through like that, like the way I set that up was a little odd. Totally unintentional. So the Revigorator water jug, for example, if you've ever heard of Fiesta ware,
Oh, I've heard of that.
that is radioactive as well, the paint they used. And most of this stuff is highly collectible. So there's people who do nothing but collect this stuff. Now, I mean, some of it's lost over time because, 1940s, 1950s, we're still, in fact, they develop a makeup line in the 1950s that adds radium. And it's like still a thing. And so in the same way that we toss out things now, not knowing their value, I mean, things get tossed out. So you undoubtedly have some of these water jars just chilling in the random landfills, which is actually kind of terrifying now that I say that out loud. I'm gonna have like a panic attack. But anyway, but you have a lot of collectors. So a lot of people do. They go to eBay. They go sometimes to big time like Christie style auctions, and they're like, here's a gnome. If you watched Bones, right? Like here's a radioactive gnome. And it is a big time trade.
Do they have to probably store it safely?
Some of these things, now sometimes the radioactivity and the radiation is low enough that it's not harmful because like natural radioactivity is a thing, right? If we had a Geiger counter, which talk about iconography, if I went and had like the picture, y'all would know what the Geiger counter was doing, right? And we're all emitting some levels of radioactivity. It's natural. We're probably emitting more than we should, right, through what we eat and drink. But for a lot of these, they're not fatally radioactive, and they don't have to be stored in a safe way, although that doesn't mean long-term exposure is a great thing. But you do also have a lot of collectors will have special rooms set up that are meant to sort of, their lead line, for example, and are meant to block some of the radioactivity. Yeah. Other questions? Yeah, Daisy.
Okay. I'm interested, Angelo. So you said was it Hickory Reservoir?
Aquifer.
So how did it become radioactive? Has it just naturally been like that, or did we do something to it? Why is that our backup? I feel like that is like our current water source.
That is not our current water source. That is just our backup water source. And the plan though would be, and this goes back like 10 years, so I don't even know what they're doing with it now. It was like the big scare back around 2014 and 2015 because I was pregnant and my mom was like, you have to drink bottled water. And I was like, it's not even here in our city yet. But the plan is to mix it with NAS-worthy water until it meets potability standards. But the point is there's some problems with natural radioactive sources, my understanding at least, but that there's also some pollution sources contributing to it. But the Hickory Aquifer is not our current drinking water. Let me just assuage your fears there. That is not where we get our water currently. That's why we want our reservoirs to fill. And their plan all along was to, or at least some of the plans were to find alternative sources. And I'm sure they've been working on that in the last 8 to 9 years. But yes, in theory, at least unless something has changed, our backup water supply has to be treated for potability, you might say. Yeah. Yes, Daisy.
Sorry, I thought you keep asking questions.
That's okay.
So one thing I was interested in, when you were talking about the environment on animals, I know in Chernobyl there's been a lot of look at what's happened to a lot of the animals that have been left behind, like the wild horses, there's some wild dog stuff, all of these, they basically an ecosystem. It's very fascinating because it's people have left, this has been totally abandoned, you have nature kind of coming back. and reclaiming, and you see like either like what's happening to animals with their cancer, stuff like that.
Mhm.
Have we been able to see similar things, or like what's happening to the wildlife of these areas that are so highly irradiated, or like have had issues with that?
Yeah, there's some positive consequences. Consequences is like a loaded term. It sounds negative, right? But there's some positive outcomes here. Nature finds a way, to quote that dinosaur movie, right? Like, nature finds a way. And at a lot of these Superfund sites even, they become, in Chernobyl as an example, they become like wildlife refuges. Because they're places where people generally are absent, and it removes pressures. Now, admittedly, you have higher rates of, sheep born with 2 heads, right, and 5 stomachs, or no brain, and like you have a lot of birth defects in your animal populations. But you are going to see that at some of these sites, not Bikini Atoll, to my knowledge, it might be there as well, but that's still very irradiated. I'm just sure you have wildlife returning there too. But in Nevada even, for example, you have these wildlife refuges, and you have this sense that some animals are going to take advantage of that lack of a human presence, or that reduced presence. But of course, there is a natural adaptation that has to occur. If you are living somewhere that has been irradiated with 300 million curies, right, of radiation over the years. Yeah. Other questions? Yeah.
So I'm wondering, are there just Superfund sites in Dallas, or are there some across Texas, or are there even some closer to us here in San Angelo?
Oh, they're all over the United States. I don't know of any ones closer to us, but that's not impossible that there would be, because some of them are small. But my guess is the ones in Dallas would be the closest. But they're all over the nation, And a lot of them are not just nuclear facilities, but just military bases in general, and weapons production facilities just more broadly. So it's not just nuclear weapons that are pretty ecologically polluting, just the creation of a lot of this armaments and weaponry has a cost. Yeah. Other questions? Yeah, Daisy.
So nowadays it kind of feels like we kind of like created something to see what happened. We didn't think about really the consequences, and now we're stuck with all this waste. We're like, or whatnot. Like, what do we do with this? We didn't think this one through. And did they ever have, what was it, kind of like that moment of realization for like just like the military governments, where they're like, oh, we just keep creating all these missiles, but like, what do we do with them now?
Like in terms of how to deal with the ecological consequences?
Like how to dispose of like all this stuff, this waste speaker that's not going to go away, like it doesn't just decompose?
I don't know of any single moment where officials were like, what have we created? I mean, of course you have Oppenheimer and I Am Death, and this sort of realization of, whoa, we've unleashed a genie, right, that can't be put back in the bottle. And famously, Oppenheimer opposed vocally the hydrogen bomb and was against its creation. And I mean, some of this hasn't been declassified, so it's entirely possible that you have military officials who are like, this is a tragedy, we don't know what to do with this, but for national security we need to press on. And that's possible, but there's not a single moment that I've seen, at least, where people are like, oh yeah, we don't know what to do with this. In fact, pretty immediately we're like, oh, we don't know what to do with like some of the consequences here. Yeah.
All right, so to be respectful of everyone's time, Dr. Archer will be down in front if you have any other questions for her, but let's give her a round of applause.